4.7, use isosceles and equilateral triangles. We've already studied what that is. Isosceles is two sides the same length. Equilateral triangles have all sides the same length. Base angles theorem, it says if two sides of a triangle are congruent, then the angles opposite them are congruent. So if AB and AC are congruent, then the angles opposite them, so angle C and angle B are congruent. The converse is the exact opposite. If I have two base angles congruent, remember this can be on any side, it doesn't necessarily have to be on the bottom. So if these two angles are congruent, then the two sides are congruent, which is AC and AB. Corollary to the base angles theorem, it says that if a triangle is equilateral, then it's equiangular. So that means if all the sides are the same, all the angles have to be the same. So the first example, you're asked to find X and Y. Notice what's given to you. These three side lengths are marked with the same tick marks, which means they're all the same length. So this triangle with these two side lengths being the same, that means this is X and this is also X. So I can figure out what those X values are by saying X plus 50 equals 180. And that's exactly what I did over here, which means my X's are 65. Now that I know that this is 65, I know that these two angles have to add to 180 because they're a linear pair. Subtracting that out, I get 115. Now that I know this is 115, these two side lengths are the same on this triangle. So 115 plus y equals 180. Subtract that out, each of these y's is 32.5. Next example, very similar. We have three side lengths that are the same, and then we have three angles that are the same in this triangle. So 180 divided by 3, each of these angles are going to be 60. In this triangle, both of these are marked as the same, so both of these base angles are going to be 50. So looking at my solution, we just talked about how these are all 60. These are both 50 using this as a straight line. 60, 50, and 70 would make up that straight line of 180. Because these two markings are showing that these two sides are the same, if this one's 70, this one's also 70. So 70 plus X is 180. Subtract that out, you get 40. Over here we have 50, 50, and Y equals 180. Subtract that out and you get 80 for Y. Example 3. So notice that we have three side lengths over here the same. Because of that, we know that all the angles are the same. So sides are the same, so that means that each of these is 60. This is marked as 90, so if this part is 60, this would have to be 30 to add up to 90. So there's my first equation, 4x minus 2 equals 30. Solving that, you get x is 8. Because these two side lengths are marked, that means that if this one's 30, this is also 30. So I can set 7y plus 9 equal to 30 and solve that and get y equals 3. Finding the perimeter of a triangle. That means we need to know all three side lengths. Because these two base angles are the same, that means that these two side lengths will be the same, and that's where our equations come from. So I set 4x plus 3 equal to 8x minus 15. When I solve that, I got x is 4.5. But in order to find the perimeter, I need to plug it back in to find those side lengths. So I plugged 4.5 into this expression, and this expression. And I got the side lengths of 21, 21, and 30.5. Of course, perimeter is adding together, and I get a total of 72.5 meters. We have a proof to go over, which is rather lengthy, but it is partially done for you. So let's just go over and discuss it. So starting off with your given statement, that came directly from your given statement. The next one, NK and NL. If you look at our picture, because I know that angle 1 and 2 are the same, NK and NL have to be the same using the converse of the base angles theorem. Looking at the difference between 2 and 3, 2 says they're congruent, 3 says that their distances are equal. That's the definition of congruent segments. Again, angle 1 and 2 are congruent. That's given, that came right from up here. Definition of congruent segments, it says that if they are congruent, their distances are the same. Addition property of equality, if you look at step 5, you still have the JN, you still have the MN. What changed is we added NL to both sides. Segment addition postulate, if you look at our picture, JN plus NL equals JL. Two little pieces give you a big piece. And MN plus NK equals MK. For number 8, we're really combining a little bit of 3, 6, and 7 to say that JL and MK are congruent. From 8 to 9, distances are the same, which means they are congruent using the definition of congruent segments. KL equals itself, that's our reflexive angle. That's part of both the triangles. Then JKL, these overlap triangles, JKL and MLK are congruent using side angle side. And because of that, I'm allowed to say now that JK and ML, which are part of those triangles, are congruent using CPC-TC that we learned 2 blocks ago.